We'll have a look at this problem here where we're given our displacement and kg, and we're asked to use our data booklet and see if the vessel complies with the current load line regulations with regard to the statical stability curve. Well, let's just look at the values that we need. For stability criteria, we've got these written down here. Minimum GM 0.15, maximum GZ at least 0.2 at an angle of at least 30 degrees. Okay, so the minimum value is 0.2 at a minimum of 30 degrees. The area under the curve up to 30 degrees, a minimum of 0.055 meter radians to 40.09, and between the two, 0.03. Okay, well, the first value we can check, of course, is our GM. We know our displacement and our kg, therefore we can go into the hydrostatic particulars with 18,000 tonnes. And in this instance, oh yeah, we're in salt water. If we weren't told it was salt water, it didn't have a density, you would always assume it was salt water. So we're going into 18,000 tonnes, km 8.4. Compare that to our kg of 8.1, and we can see straight away that the GM, the vessel, does comply with the GM. Now, just because it complies with the GM doesn't mean that's it complies. It may be that the vessel has a high GM, and for example, if it's got a very low freeboard, deckage immersion could occur very early, and therefore the area under the curve, it may not comply. So let's have a look what we have to do. We have to use the KN tables, and with the KN tables we're going with our displacement and pick off all the KN values. Once we've got those, we know from our formula sheet to draw a GZ curve we use this formula, and it is the only time we use it for the GZ curve. GZ is Kn minus Kg sine theta. Kn values from the table, Kg were given in the problem, sine theta are the angles at which the Kn values are obtained at. So from the Kn tables we obtain angles at 12, 20, 30, 40, 50, 60 and 70. Get the Kn values. Kg sine 12 degrees with Kg at 8.1. So there's our Kg in the problem, 8.1. So that's 8.1 sine 12 degrees, 8.1 sine 20, 8.1 sine 30, 8.1 sine 40. I'll go on and on. Kn minus Kg sine theta equals Gz. So your formula sheet tells you that Gz is Kn minus, so that value Kn minus Kg sine theta will equal your Gz. So there are all our values of Gz written down. We then draw the curve. There's our, on the y-axis are our GZ values, there's all our angles. Now be careful, 10, 20, 30, 40, 50, 60, 70, 80, we want 75 and 12, so make sure you don't put this 12 degrees value 0.07, don't put it at 10, put it at 12 degrees, and of course 75 as well, between 70 and 80, although that's not really relevant, that one. So therefore we've got our GZ curve drawn there. Why do we need to draw that? Well, we need to work out the area under the curve up to 30 degrees and the area under the curve up to 40 degrees. And we also have to look to see what our maximum GZ is and the angle at which the maximum GZ occurs. Well, we can see that the maximum GZ is 0. Angle of maximum GZ occurs at 30 degrees. So curve there at 30 degrees. And it's 0.2, so sorry, 0.22. So the angle of maximum GZ at 30 degrees value is at 0.22, and if we look at our values here, 30 degrees, 0.22, you can see it's the maximum value. So it just complies with those two. So the final thing we have to do is work out our areas under the curve, and this is where we use Simpson's rules. And with Simpson's rules we have to always start at 0. Okay, so when we're going to 30 degrees it's 0, 10, 20, 30. We get our ordinates, in other words our GZ values. Well, at 0 degrees we know it's 0. 10 degrees we would have to get that from the GZ curve because we only had 12 degrees. 20 and 30, of course, we've already worked those out. we've already got 20 and 30, 0.16.22, so we've already got those. Use the Simpsons multiplier, because there's 4 of them there, an odd number, 1331 will work. The 141 rule won't work for this, it's 1331. 1 times 0, 3 times 0.06, 3 times 0.16, add them all up. Use the formula 3/8 times h, which is the common interval, which is the interval between the angles, which is 10 degrees. But don't forget, you must divide by 57.3 because it's meter radians. So it's 3/8 times 10 over 57.3 multiplied by the 0.88. So up to 30 degrees it's 0.058. 0.058, so it just complies up to 30. What about up to 40? Well, again, write down 0, 10, 20, 30, 40. You must always start from 0, write your ordinate values, then work out which Simpsons rule to use. And you can see 1331 won't work for this one. So it's 14241. Okay, 14241. Hopefully you're conversant with the rules. This is the 141 rule, but because it's more than 3, it's 14241. Depending on how many you had, it will be 142, 42, 42, 42, but it has to end 41. Okay, again, same principle, multiply one by the other, product area. Because it's the 141 rule, it's now 1/3 times the sum of the common interval times the product area, whereas the other one was 3/8. So the area we got was 0.093, just complies. Difference between the two gives us the area between 30 to 40. Again, that just complies. So the vessel just complies with all the criteria. So you just have to be aware how to use Simpsons rules. And a common mistake students make is to miss the 0 degrees. I know the value is 0, but you have to start at 0, because when you're working out the area under the curve, it starts from 0. So you can't start from 10 degrees, it has to start from 0 to give you the proper value for the area under the curve.